So everything is okay? No questions? Yes.
I was gonna ask, 'cause I didn't catch you.
Yes, Brandon?
Catch what you were saying in the beginning. You
Yes.
the test for next week. Is it going to be on that Monday or that Tuesday? We have to take the test by.
So we can talk about the test at the end of the class. The test is next Wednesday, the 2nd.
Okay.
But we have to make a decision. I think we should talk about it in more detail on Wednesday. Because I would like to have a review before the test. So we'll see. Theoretically, for now, it's scheduled for October the 2nd.
Okay.
However, we come back to class. So please don't schedule it during class time. We will continue on Wednesday. Okay? So please do not miss class, and when you make arrangements, don't miss class on Wednesday. We cannot afford to miss class. Any class. Okay. So I'm going to share my screen. I'm going back there to modules. I had to add somebody on the test, so I'm going back. Okay, I'm sharing the screen so I can show you where we are. You all have all the handouts are posted. Okay, so what I recommend moving forward is to choose some, not all of the problems on the handout so we can get to where we're going. And when we review, we will pick anything else we have not worked on. So like always, I let you decide. So we ended up last time with 47. So now let's choose. We continue. Please choose what you would like us to review with. These are all review from 145. And I would like...
58.
Yes, which one?
58.
58, perfect. So let's continue with 58. So 58 has 3 raised to 2x plus 3 raised to x minus 2 equals 0. Perfect, thank you. Before we work on this problem, first of all, we have to identify what it is. We know it's an equation, but what type of equation? We've seen, so far, we've seen linear. We've seen quadratic. We've seen rational. We've seen radical. We've seen, although these are polynomial, in general, polynomial higher degree. We've seen exponential last time. What type of equation is this? We need to be able to understand or identify it correctly in order to be able to solve it correctly. Can anyone give us an idea?
Logarithm.
Okay, so a log equation, we haven't gotten to it, but it has to have something called LOG, or LOG base whatever, or LN. If I don't see LOG of with some base, or LN, this equation cannot be logarithmic.
Sorry, I meant exponential.
Excellent. I completely agree with exponential. One thing I would like us to refresh our memory on, at least the two graphs, exponential and log, with base greater than 1. So I hope you remember that this is the shape of e to the x, 10 to the x, 2 to the x, 4 to the x, 3 to the x, and so on and so forth. Any number greater than 1. So this is the exponential function. Are there any restrictions on the exponential function? Because remember, we had restrictions here. The denominator could not be 0. We had problems, potential problems here. Sometimes we found extraneous solutions. So I would like to identify whether the exponential function is of this category where I have to worry. Do I have to worry about the exponential function? What is its domain? It's okay if you're wrong. We have to communicate.
Is it negative infinity to positive infinity?
Yes. I call this friendly. Friendly. I don't have to worry about it. It's defined with all real numbers. Excellent. Good. Now I have to graph its inverse function. And it has to be also increasing like the exponential function with base greater than 1. And we have this. And we will discuss this when we look at transformations. They have to be symmetric with respect to, assuming they have the same base. E to the x, natural log. 10 to the x, log. 2 to the x, log base 2 of x, right? So in the same order, natural log x, and log base 2 of x. Y equals x. And you will see why I made this analysis. Now let's put in the natural log or log base 2 or any base greater than 1 for this particular scenario. Let's put it in any category. Is it a friendly function? What I call friendly is I don't have to worry about its domain. Is it friendly or not friendly? So what is the domain for this? Or for this? Or for this? Look at the graph, very easy to identify.
All row numbers.
Let's look at the graph. We're looking at the red graph.
All real numbers greater than 0?
Exactly. All real numbers greater than 0 and not 0. Excellent. Perfect. So, unfortunately, this function will join the other two. Not friendly. Potentially friendly, but I have to worry about them. I'm not saying that they cannot be friendly. I'm saying I always have to worry. Denominator cannot be 0. Here, I may not be able to take the square root because it's a negative number underneath it. And here, log cannot be applied to negative numbers. Of course, not even 0, but not to negative numbers. So this analysis will help us discuss this and any other exponential or log. Okay, now let's finalize our problem. So let's start with it. 3 to 2x plus 3 to x minus 2 equals 0. Any questions before we continue with this? Anyone? Okay, good. So any suggestions on this problem? Please communicate. It's okay if you're wrong. I mean, I hope you're wrong so I can teach you something. I didn't want to sound like that, but you know what I mean.
Move 2 to the other side by adding it.
Perfect idea. So we move 2 to the other side, and when we apply natural log, we cannot apply to a sum. So maybe we should also review the properties of log. Okay. So we have 3 properties. A product, log applied to a ratio, and log applied to a power. Let's say x to a. So notice that even if you move 2 to the other side and you try to apply natural log to this, there is no property that allows us to further simplify that. So log of a plus b, or log of a minus b, is carved in stone. Similarly to, we discussed this, a plus b. This is also carved in stone. So there is no property that allows us to simplify log applied to a sum or a difference, like there is no property for the square root of a sum or a difference of terms. So these are the only options. That's why it's tricky. Yes, if we do that and we apply natural log, we get stuck. We're not going to get anywhere. So anyone would like to refresh our memory quickly on these three properties since I mentioned them here, or they're written here? Anyone? Any of these, please. Anyone?
Log of A times B is log of A plus log of B.
Excellent. Of course, in any base. That's why I didn't even put it. It's assumed to be 10. We don't write it by convention. Okay, good. Excellent. Who was that? Jalen. Thank you, Jalen. Good. The next one.
Log A minus log B.
Exactly. And the last one. So this is the same. But just minus. This is plus, this is minus. Excellent. What about this?
I believe with the A at the beginning.
Yes. As a factor. Please do not put plus or minus. I didn't say you said that. I just want to emphasize. So please don't put plus or minus. This becomes a factor in front, log x. Perfect. So the idea, because there is a sum here, we have basically three terms. If we had only two terms, yes, I would have said, yes, that's the thing, that's a step, move to, apply natural log or whatever log you want, and it's done. But not with three terms. Excellent. We had a method that we employed a few sessions ago, or last session or 2 sessions ago. And let me just give you an example, and you will identify it immediately. So we had something like, I don't remember the exact problem, I'm just going to make a problem up. And that's my page 2. So let's say y to the third, y to the 6 minus y to the third plus 1. I'm not saying that we want to solve this, but we came up with something. And why? Anyone remembers what method we applied here?
Substitution.
Yes, exactly. We said we were looking for quadratic in form. So this equation is quadratic in form. In other words, it can be replaced by a quadratic equation. So let's come back to our 3 to 2x plus 3 to x minus 2 equals 0. So, is there anything in those lines that we can do here? Assuming we remember something important. Is there another way of writing 3 to 2x? Because if we don't remember another way of writing it, maybe we will not be able to see what the next step is. Is there any way of rewriting 3 to 2x that makes sense in our situation? It's okay if you're wrong. Tam, anyone? Axel?
3 to the power of x squared.
So you really meant 3 to the x and everything.
X squared, yes.
Correct.
And then you can do 3 to the power of x equals. Yeah.
Exactly. So then you're saying that this should be t, and then this should be
E squared.
yes. So it turns out that this is indeed quadratic in form. Nice. So t squared plus, plus t minus 2 equals 0. I know that somebody will factor this for us quickly.
T minus 1, t minus 1.
So careful, remember the product is -2 and the sum is 1.
Oh, I mean t
So we want the product to be
minus
-2.
t plus 1.
So t minus 2 and
T plus 1.
okay, let's try. We have to make sure that this works. The product is -2, but the sum is not +1. So -2 times 1 is -2. Check. But -2 plus 1 is not +1.
Just
Oh, so plus 2 minus 1.
Excellent. Indeed, that is correct. Good. So then we have two t's. Okay, what are the options for t? T equals and t equals.
One and -2.
Okay, excellent. Is this sufficient? Are we done?
No.
No. So this is a new equation, this is a new equation, and the new equations are, can anyone give us the new equations? Which two equations do we have to solve now?
Three to the x equals -2, 3 to the x equals 1.
Excellent. Our little analysis from a few minutes ago states that whenever we look at an exponential function, if it's a pure exponential function like this one is, pure, no transformations, nothing on it, pure, the domain is all real numbers, of course, but the range is positive. So what I'm trying to say is that this is not possible. That's one way of knowing it. Here you would have said, well, apply natural log to both sides, but I can't, not to a negative number. So that's another way of knowing that this equation has no solutions. Now I need to solve this one. So 3 to the x equals 1. There is no need for natural log because this is too easy. 3 raised to which power is 1? X must be
0.
That's it. So please remember, one option is to always have the graph in your mind, which is quite easy. The other option is you will say, oh, well, I have to apply natural log, but you won't be able to. That was another analysis from a few minutes ago, only because, as you see, the log function is defined on 0 to infinity. You cannot apply 0 and plug 0 in it or anything to the left of 0. Good. It was a good example. Let's move on. Any questions about this problem? Anyone, please take a moment and let me know. Okay. I think we are ready for logs. So let's choose one, maybe two if you'd like, for logs, and then move on so we can make some progress. Any problem, you choose. We'll do the rest during the review. Any preference?
Let's start with the first one, then
17?
yeah, then
Okay.
the ones with the ln.
So you want the 17 and which one?
25.
17 and 25. Okay. 17, 25. So let's start with 17. So we have log x plus log x plus 15 equals 2. Perfect. Okay, first of all, what is the base of log?
10.
Yes. So please remember, thank you, Chris. So I just want to make sure that you have right here. See, log, the key log goes together with 10 to the x. So that's another indication that log has base 10, log has base 10. And of course, ln shares the same key, of course, with the second feature or not, with e to the x, y. Well, these two are inverse functions, inverses of each other, 10 to the x and log, e to the x and ln. So you should always remember the base of ln is e, the base of log is 10. Okay, so that's one thing. The other thing, I'm going back to our previous analysis. Log is a problem, or potential problem, like radicals, depending on the index, of course, and rational depending on whether the denominator can be 0. So when you see these three, a light should come on, reminding you, oops, well, I have to be careful. Okay? So I see log of any base, it doesn't matter, it's the same thing. Okay, so there are two options here. Two options. Option number one, you check the prospect solution. Back in the original problem. The other option is, which I prefer, but you don't have to, but you must choose one or the other. You don't have to be consistent. For this problem, you may choose this. For another problem, you may choose this. It's up to you, but you must choose one or the other, like we did here. We had no choice. We had no choice. We have no choice. So, the other option is state domain. This is my choice, most of the time. Your choice may be this, which is fine, but I like to discuss this one. Now, let me see where I am. Yes, allow